Hello ladies and gentlemen, hope everyone is doing well today. We're going to continue on with Chapter 7, this time taking a look at Section 7.2, which is hypothesis testing for the mean. And in these examples we're going to assume that the population standard deviation is known. Now, the material that we're going to cover today is going to give us a nice refresher of Chapter 5, particularly with the normal distribution. And if we recall from yesterday, we started to take a look at what a p-value was, as well as what alpha was. And these are going to be sort of our parameters to determine whether we can reject or fail to reject a null hypothesis. So there are three particular tests when it comes to hypothesis testing. Taking a look at the first one, we see that the alternate hypothesis is when mu is greater than some value, or vice versa, the null hypothesis is mu is less than or equal to some value. So your p-value is just going to relate to finding the area to the right. And if you recall, Chapter 5 showed us that if we wanted to find the area under a normal distribution curve, we needed a z-score. And so that's going to be a crucial aspect when it comes to all three of these cases. Now, kind of on the opposite spectrum for a right-tail test, the left-tail test, given these hypotheses here, tells us that our p-value is going to be an area to the left of some z-score. And then the two-tailed test is a unique case. If your population parameter is not equal to or equal to a value for the alternate or null hypotheses respectively, then your p-value is just going to be 2 times the area of one tail from your normal distribution curve. So if you decide to find the area, say, to the left or to the right, you can just choose one of those two values and then multiply it by 2. Signifying the p-value for this particular scenario. And if your p is less than or equal to alpha, then you're going to reject the null hypotheses. And if p is greater than alpha, then you're going to fail to reject the null hypotheses. And essentially what alpha is, it's just the boundary that we have for the area in these particular scenarios here. And so let's see what that actually means in the context of a real-world problem. So let's suppose that an inventor claims that his new car engine will last at least 300 minutes per gallon on average. Now he takes a sample of 50 engines. He found that the sample mean was 295 minutes and the population standard deviation was 20 minutes. And we're going to assume that this data is normally distributed, and we're going to use a 0.05 level of significance to test this hypothesis. Now, there is a lot of information that is given here, so it would be a good idea to try to write this down on the side. That way we can easily keep track of how we can test this hypothesis here. So because he claims that the mean time for this engine is at least 300 minutes, that tells us that it's going to be a null hypothesis. So mu is going to be greater than or equal to 300. So we recall that the words at least relate to this inequality here. In turn, that tells us that the alternate hypothesis will just be mu is less than 300. Okay. Now, if you wanted to figure out the area under a normal distribution curve, Chapter 5 reminds us that we need to find a z-score. And because we're dealing with a sample in this case, we have our sample mean subtracted by our population mean, and that's going to be divided by your population standard deviation, and that's divided by the square root of n. And n in this case just represents your sample size. So we actually have all the pieces of info that we need. N in this case is 50 because we have 50 engines. The sample mean is 295. Your population standard deviation is 20. And your population mean is actually going to be the same as the one from the claim. So mu is going to be equal to 300 in this case. Now, because they also list a 0.05 level of significance, we can also identify alpha is equal to 0.05. And so the ultimate goal is to check if that p-value that we have, in this case when mu is less than 30 or 300, we want to see if that's going to be less than or equal to our alpha level. And in that case, it's going to be 0.05. Okay. Less than or equal to that. All right. So if we focus on the z-score, right, we can plug in those values accordingly. So we get 295 minus 300, all divided by 20, which is divided by the square root of 50. And if you plug that into your calculator all in one go, you just want to ensure that the numerator and denominator are both in parentheses, and that approximates to be around negative 1.77. Okay. Now, this is our z-score. If you do have your table of values, you can end up finding the area to the left of that particular z-score. Now, because we have technology on our side, if you go over to onlinestatbook.com, they actually have a built-in calculator that helps you determine what these areas are. So we're going to assume that the mean and standard deviation are 1. If they mention above, they're talking about an area to the right, as you can see here. So we want to focus on below. And so we just want to change our z-score to negative 1.77. And if I click on recalculate, right, this is now showing me the area to the left, and that area turns out to be 0.0384. Okay, so the area, otherwise known as the p-value when mu is less than 300, is going to be equal to that value that we just found. Okay, so now that we know that, we can plug this into our inequality. So we have 0.0384 is less than or equal to 0.05. So because that is a true statement, that tells us we have enough evidence to reject the null hypothesis. And in which case the null hypothesis was mu is greater than or equal to 300. So because you have enough evidence to reject this statement, that means the alternate hypothesis can be accepted. So what this essentially is saying is that for this new car engine, the population parameter, or the population mean time per gallon, should be less than 300 minutes. Okay, so we will get some more practice with these examples because it is a lot to take in, but we'll kind of take a look at it step by step to identify those parameters, see how we can find the z-score, and then in turn, once you have that area, you can compare it to your alpha level to see if you have enough evidence or not. And with that, I hope you guys have a great rest of the day.